Welcome to the community track at reInvent. I hope you're all having a good time. Day one at reInvent. I'm super excited and honored to be here. Flew all the way from Denmark to far away Las Vegas, so it's super exciting for me. Today I would like to talk about our serverless journey that we had at Trustpilot over the last 2 years. And for me it's very special because it's kind of full circle. The journey started 2 years ago here at reInvent. And I would have not imagined standing on stage 2 years later, so it's kind of really exciting for me. The slides will be available on SlideShare just after the reInvent, and then I think after 48 hours on YouTube. But before we dive into my talk, I would like to introduce myself a little bit. My name is Martin Bubel. I'm a VP of Engineering at Trustpilot. I'm an AWS community hero. I lead the AWS user group in Copenhagen, Denmark. And if you want to get in touch with me, the best places to do that is my blog or my Twitter handle. And you can also find me tomorrow at the AWS user group booth at the Expo Hall. I will be there from 10 to noon and drop by anytime, talk to other community leaders, and become part of the AWS community, right? So the agenda for today, I kind of separate in 6 different chapters. I would like to travel back in time to reInvent 2016, see where we're coming from, and then look a little bit where we are today. The next thing is what are we using serverless today? What are all these AWS Lambda functions doing? Then I want to give you a couple of takeaways, something concrete that you hopefully can take away and build. And the next chapter is a fast track to serverless. It's more like a leadership session. Think about it as like, how do you actually implement something like serverless at your company? How can you excite your developers, your software engineers to get on track with that? And then later on, I also want to give you a couple of ideas how you could implement that. And then I'm going to wrap it up just looking back, any advice, and then we have a Q&A session. All right. So the first part of it is traveling back in time. I think to understand where we are today at Trustpilot, you need to understand where we're coming from. And travel back in time exactly 2 years, back to reInvent 2016. That's how it looked back then. It was blue. Just maybe raise of hands. Who was here 2016 of you? Okay. So for me, it was really exciting. It was the first reInvent I've ever been to. And serverless was not completely new to me, but the concept of serverless and particular serverless compute, like Lambda functions, it really clicked for me 2016, right? There was so much hype around it, and it all made sense, and so I was really stoked about it. And 2016, like 2 important things happened for me. A, I had my first chicken wings eating contest. So that's in the middle, it's me. At the Chatonga Challenge. I think it was last night at the Midnight Madness. Did anybody go? But yeah, not too impressive. I think I just had 12 wings. If you didn't know that, Amazon has like that quirky kind of tradition around chicken wings. And I think they tried to break the Guinness Book of World Records last night again for the biggest chicken wings eating contest. I don't know if they succeeded. I didn't go to the Midnight Madness. And then the second important thing, as I said, serverless function as a server particular started to make a lot of sense. It was everywhere, right? Every session I went to, it was like Lambda, serverless, everything. And in particular, one crucial feature got announced, what was dead letter queues. And so for me, it made completely sense now how we could like use it in our application, in our architecture, right? Being able to have the letter queues. And I'm gonna look a little bit into that, what that means for us. And the evolution of server, from virtual machines to containers and to serverless compute, it just was everywhere. And I mean, 2 years later, 2018, they're gonna announce a lot of new features as well. So I think it's really exciting times. So for us back then, as I said, function as server wasn't a total stranger. We couldn't really move on it until February 2016. We were waiting for it to be supported by VPCs. But then we already had around 40 Lambda functions in productions, mostly like some tooling, code pipelines. and some experiments. But then at reInvent, as I said, it really clicked. And when we were back in Denmark, we said, okay, let's actively drive serverless adoption in our company, right? And how did we do that? Fast forward to today. Instead of the chicken wings eating contest, I'm going to run the 8K charity fund run tomorrow for Girls Who Code. I think we need more women in computer science. We could use a lot more, and Girls Who Code is an awesome organization trying to lower that gap, right? And so tomorrow we have that 8K run, and the profits go to Girls Who Code, what I think is awesome. But more importantly, cloud compute with AWS, what you see back from 2016 to 2018, we kind of doubled the amount of services, cloud compute services. And those are all cloud compute services. These are virtual machines, EC2s, these are Docker containers in ECS, and then serverless compute in Lambda. So if we go into the stack graph, you see what happens, right? The purple is EC2s, the blue one is containers, and then the pink one is Lambdas. And so from 2016, Lambda was like the biggest one that grew. And yeah, the chart makes it even more obvious. If you look into that in pure numbers, like absolute numbers, 180 virtual servers, to 2 years later to 95 virtual servers, we decreased that amount by 53%. From 80 containers to 283 containers, we actually grew them by 354%. And then the biggest increase really that we saw was in Lambda functions from 40 to 252, which is an increase of 630%. I'm going to make this big for a second. We're not a super huge engineering organization. I think we have today around like 80 engineers in 2 offices. So we didn't stop building other things, right? It was just we already had a microservice architecture, and Lambda just started to feel really, really good and to fit in our architecture. So the next question that you probably have is then, what are all those Lambda functions doing, right? And that's what I want to look into next. So high-level architecture for me is I can break it down to 3 things. We're cloud native. I think we're for 5 years now complete in the cloud, don't have a single server on-premise. We're an event-driven microservice, or we have event-driven microservices, mostly kind of near real-time architecture. So we're not a financial institution, we're not ad tech, we're talking milliseconds to seconds, right? So we don't really have to be live, and then everything is abstracted with REST APIs. If you look in our architecture, like really high level, the top layer is kind of our web interface layer, web clients and like web applications. And so we have multiple applications. Those are 3 examples that sit on top of our API management layer, and as well as third-party applications that communicate with our API management layer. And under the API management layer, we have a PubSub messaging system with SNS and SQS. And then below that, you have like the traditional compute layer and the data layer. And then you would even further, you have like a data lake for data compute and so on. But the 2 areas that we have AWS Lambda functions the most is in our REST APIs. And that's probably not too surprising, right? If you know API Gateway, they integrate really nicely with Lambdas. So that shouldn't be too surprising, but today a lot of our, AWS Lambdas are actually in the compute layer. And what they do is they subscribe to our SNS PubSub messaging system. If you don't know about PubSub messaging system, I'm going to introduce it like in a really, really brief form. So you have publishers on the left and you have subscribers to the right. And publishers send events to the PubSub system with a certain topic, and then subscribers subscribe to that topic. And the interesting part is that multiple publishers can publish multiple messages with the same topic, and then subscribers instantly get all of these messages in a distributed way. If you think about it from like network topology, it would be kind of like a star diagram, right? And if you AWS-fy that a little bit, that's how we traditionally autoscale before we used serverless compute, right? We have publishers that send messages to SNS with a certain topic, and then we have SQS queues in between, and an auto-scaling group with ECS or EC2s that subscribe to those queues. And it's a very robust kind of system. I like to think of it as like an auto-heal system. So publishers put messages in, and then multiple services can subscribe on that. If something goes down, if some system breaks, the queue fills up. We fix the service, auto-scaling kicks in, empties the queue, and the system is back again, right? And then in most cases for us, that's enough, as long as we don't lose data. If it gets processed later, we're really good with it. The downside can be that this is sometimes a little bit slow with spikes, particularly, we had just Black Friday, right? Those ELBs, they scale a little bit slower, so can take up to 10 minutes to react to spikes. So what you usually do is you have to over-provision your clusters, right? If you anticipate any spikes. So this is how we do it today, serverless instance scaling on topics. And if I'm going to switch between those two slides a little bit. If you look between this one and this one, right? It just simplified our architecture a little bit. We basically removed the SQS queues and then are able to subscribe with Lambdas directly to SNS topics. And then Lambdas just auto-scale for us, so we don't have to think about that. And that really simplifies how we think about our systems anymore. And then let Amazon do the scale for us, right? It's really convenient. And that's where a lot of Lambdas sit today in our architecture. And if you even go further, I think 6 weeks ago it was introduced now that Lambdas can subscribe directly on SQS. And that will bring back that self-healing component that we had previously. And we're probably moving towards that architecture in the future. So if you go back to how we scale today on SNS, whenever there's an error, then we have it in a dead letter queue and then process it manually. Moving forward to this, implementing SQS queues again, we will actually have an auto-heal in our system again. So that's exciting that Lambdas can now subscribe to SQS directly. And just to wrap it up, all those Lambdas are mostly in 2 parts for us, integrating with API gateway and then subscribing to topics on our PubSub messaging system. Perfect for decoupled event-driven microservices like we have them. And the next step for us is bringing back that auto-healing. So now I want to give you a couple of ideas how you can maybe implement that at your own company, right? You might not have the same architecture like we have today, like an event-driven microservice architecture, and so it might be a little bit hard to get there. But I'm sure a lot of you use GitHub. Maybe raise of hands who is using GitHub. Okay, and then who is using Slack? Okay, so you can immediately start using that, and maybe if you don't use GitHub or Slack, I think you can probably take a couple of things away and implement it with a different system. I think the idea and the concept is pretty straightforward. So this is a system that we have. I call it Git Webhook to Slack PubSub messaging system. On the left side you have Git or GitHub, and then on the right side you have Slack messaging app. And so what you can do with GitHub is you can actually enable webhooks, and you can enable them for your organization, or you can enable them for specific repositories. And then whenever anything happens, GitHub is sending webhooks, HTTP posts to an endpoint that you define. And that's really convenient. And so if you use API Gateway, for instance, you just give that API endpoint to GitHub, set it up. Whenever there's something happening, we have it set up for our whole organization. And every GitHub event will bubble up to SNS. To API gateway, and then there's a Lambda subscribing on that API gateway, and then we fan out PubSub messaging system, right? And then there are multiple Lambdas just observing those topics, or that same topic, but looking for different kind of event types. And I'm going to show you a couple of ideas how we have to implement it, and maybe you can get inspired and implement it in your company as well. So one of those Lambdas we use for Git security audit. I'm sure some of you have been guilty of committing secrets into a repository, into source control. And if not you probably know a coworker who did it. For us, it happens all the time. It's just, you know, a simple mistake. And yeah, it's not the end of the day, but we want to be sure that we catch it, right? And so here it's really easy. We just look at every commit, have a couple of patterns that we research the commits for, and then whenever we see something that is like, we think follows a pattern that might be like either one of our own API keys or a private certificate key or a connection string that we don't want to see in source control, we bubble it up into a specific channel and select secrets, and then people subscribe there and then can say, okay, this is okay, this is not okay. And it links back to your GitHub account, and then people can have a conversation and then potentially like you know, remove that commit from the GitHub history. And so that we use that all the time. And then the version 2 of that, actually we have that implemented as well. Instead of communicating back to Slack, what you can do, you just call GitHub's API and then have a message directly attached to the pull request that says, hey, we found potentially some secrets in your commit, and then you prevent them from merge it, from automatic merge, right? So that's could be version 2, how you implement that. Another idea is AWS Lambda for Git privacy audit. Particularly in Europe, we had GDPR happening for us, and it's not only secrets these days that we're concerned of people committing to repositories. It's also PII data, like personal identifiable information, like email addresses, customer names, social security numbers, and so on, right? We don't want to have that in source control. And I see that more and more, particularly with data scientists or data analysts, when they train models. They use those training sets and then they accidentally commit them to GitHub, right? And we don't want to have that in source control because we would get in trouble with an audit. So this is basically the same Lambda, in a little bit different, looks for different patterns, looks for PII data, and then alerts you in Slack as well, just for privacy audit. So that's another thing that we're using it for. A third idea that's really popular is naming discussions. So whenever we create a new repository in GitHub, I think we have close to 950 repositories today. We bubble that up into a Slack channel, and then people can get involved. Some are really passionate about it and always have an opinion of this is the right name or it should be the wrong name. And you know, it's a really hard engineering problem. And like naming, it's as funny as it is, but it seems to still be complicated. We see like the Smurf patterns and you name it, right? So I've blacked out all the developers there to protect them, but yeah, you get an idea. And I'm sure you have the same problems in your company as well. And then the last idea I want to share is AWS Lambda for Trello integration. So we have it automated whenever we send up a pull request to match that pull request to a Trello card. Trello, if you don't know, is like a Kanban workflow tool that we use for project management, for Kanban, like moving cards in lists from left to right in a Kanban way. And then we attach those GitHub pull requests automatically to those cards if we find a connection there. And that's really popular. And so you see it in Trello, but then also we connect it back in GitHub, the Trello card, so you have the links in both directions. All right, just to wrap that one up, GitHub Webhook to SNS pops up. We have it as GitHub security audit, we have a privacy audit, naming discussions, and then a Trello integration. All right, the next thing I want to look into is fast track to serverless implementation. So how did we, in leadership, drive it? Like whenever we want to really go into something, we start an initiative and call it fast track. 2 years ago, we started fast track to serverless. Last year, we started fast track to machine learning. And for us, it's really an initiative, like get in those systems, get in those technologies like as fast as possible, right? And well, yeah, as I said, we came back 2016, we're really hyped. And thought about like how could we make this happen? How can we excite our engineers? Well, how could we think about increasing the adoption to like what we have today, to 630%. So we have engineering principles at Trustpilot, and an engineering principle is something that's true for us, right? So this doesn't have to be true for you and your organization, but for us, an engineering principle describes either the world how we have it today, or it can kind of push the bar and make it describe something where we want to be, and then kind of sets that in stone. And it's really powerful. We don't have a lot of those. So we created an engineering principle called Serverless First. And if I read it, it's if serverless is not available or practical, containers are recommended, virtual servers, EC2s are considered legacy and should be avoided. And so for me, when I wrote that principle, it was really clear, like a flowchart kind of in my head, right? You start with serverless. If that's not practical, well, then use containers. And that's kind of it. Like containers are today mostly like a catch-all for your system. And there are really just a few examples where we still use EC2s today, like orchestrating ECS and so on. So what happened? Oh, by the way, we also open sourced that, so if you want to look at our principles, in particular the serverless first, go to github.com, Trustpilot principle, and you'll find it there. But what happened then is our engineers were not happy with us, right? We released this, and everybody was like, yeah. And so we had to kind of like feel a little bit like what was going wrong. So we first introduced it with our tech leads, and as I said, it was a bit heated, and so they didn't like it. Right? We come back, we're excited, we say, okay, here's the principle, and they didn't really like that. So back to the drawing board, and I'm not sure if you know that one. It's called the Golden Circle. It's was introduced in one of my favorite books by Simon Sinek. Start with why, and if you look how we wrote the principle, we clearly missed the why. We didn't explain why we're doing this. We just explained the what, right? Like serverless. So we started to think about adding the why to our principle. And this is a wall of text. I'm going to read it and then we take it apart, right? We do this because we strongly believe that serverless, function as a service, backend as a service, and database as a service is the future of the cloud, and we'd like to be on the forefront of that movement. Serverless might not be necessarily the right choice for everything today, but start your architecture discussion there. We're in the process of fading out virtual servers and want to avoid creating new ones. The benefits of serverless and containers over virtual servers are diverse, simplified and faster autoscaling, better service orchestration, reduction of cloud service costs, reduction of operational costs, and modernizing our cloud stack. So let's break this apart a little bit. So we communicated a vision. We said we want to be part of this movement, the serverless movement, right? I think that's powerful. We acknowledged in our principle that it's not always the right thing to do. Particularly if we had a few, legacy stacks or orchestration stacks for ECS, that helped. I think sometimes engineers think it's like black and white, and that's not really what we want. We just want to drive adoption. And then one thing that for me was really important, we wanted to modernize our cloud compute stack, right? We back then, 2016, had still a lot of our stack in EC2 virtual machines. And we could have also just adopted it to, or moved over to containers, but we wanted really to go one step further, go to serverless and then containers. And then, yeah, we see operational benefits. We see some operational benefits in serverless, like our DevOps SRE guys, right? They don't have to spend their precious time anymore thinking about autoscale and load balancing our systems so much. It's done in a managed way for you, so we can move those resources to other important things. And then the last thing is we anticipated some cost savings, right? And so what happened is our engineers were a little bit more happy, but there was still like a few folks that kind of were raising their eyebrows and said, like, we don't really buy in yet. And the problem was this sentence here: virtual servers are considered legacy and should be avoided. And we had a couple teams that had .NET systems, and those were exclusively in EC2 on Windows machines. And there was no real reason or like possibility at that point for them to move into Docker. It would have basically declared the entire stack as legacy, and they just didn't like it. So we had to go back to the drawing board with those teams and define kind of like a migration strategy for them where they were happy. We had a couple stacks that we supported at that point. It was .NET, Python, and Node.js. But yeah, for those teams, that meant a lot of work, right? And so we had to kind of like hold their hand and work them through with it. And then so what we did basically is we said we were going to move forward with .NET Core, which was kind of early days back then. But we did a couple of prototypes, and we felt we felt comfortable with it, and particularly the migration work that had to go into it from those .NET frameworks to .NET Core. .NET Core, if you don't know it, is Microsoft's open source version of the .NET framework that runs on Linux. So it plays really nicely with Docker. And once we felt comfortable and the decision was made that those teams can move forward with .NET Core and Docker, then I think everybody was pretty happy, right? And as you see today, we increased the amount of Lambdas by 630%, and I think all teams have Lambdas now in production and are really happy with it. So keep that in mind when you introduce like engineering principles, that if you have any hard dependencies, you might want to think about them first, right, before you just get too excited and like push it on your teams. There are a couple of other ideas that I want to share with you how you can drive adoption of serverless in your company. Besides that serverless first principle, and maybe you get inspired and maybe you do some of them as well. So what really works well for Lambdas is hackathons. And it's perfect, right? Because now we can build things that actually scale for large systems. And before that, so we do frequently like 2-day hackathons, and before that we had to put a lot of lipstick on the pig, we had to cheat a lot, and we could never release anything that we built in 2 days to production. And what we saw once when we had a couple of themed hackathons around serverless, right? We saw that in 2 days teams could build something that like actually felt like it would scale. The problem with that is just because it should scale, or you think it will scale, you probably most likely don't want to just ship it to production, right? And that's a problem that we faced back then. So we created another thing called labs. You probably know that from Gmail. It's very famous from Gmail, where you just go into settings, enable labs, and you can toggle a couple features. So we built that for our product, and so basically just like a playground for our developers to release features that they build to production, and then customers can come in, toggle them on or off, and play with them. Of course, we have a big disclaimer there, and that it might break, it might go away, we might not support it, and so on. But a few of those that we built in hackathons based on serverless are today in production. And I think that's super exciting if you just can build something in 2 days, an idea that you have as a developer, execute it, push it to labs, and then you see that it's actually used, and somebody catches that ball, a product manager, and we really release it and make it part of our big product, right? So hackathons in combination with like a safe way of deploying those to production, I think is really powerful with serverless. This is another thing that we built in a hackathon. It's not a production system, but we call it the trust map. And it kind of just visualizes amount of reviews that pop up with geo coordinates around the globe in real time. And it's pretty mesmerizing if you look at that for like a little bit too long. But the implementation is super easy if you think about it. On the left side, we already have those review creations as an SNS topic in our system, so we just have to build a Lambda that subscribes to that topic, analyzes the geo coordination, and in this scenario we put it into like a Elastic Cache Redis to cache it for 24 hours to like have that heat map, so to speak. But that's it, kind of, and then the front end is just a simple JavaScript application that, that reads on top of that, right? So this is something that I think that looks really, really cool and is powerful, and the implementation, the backend implementation was just so easy to do, based on serverless, but then also on top of our SNS pub sub, right? Another thing that we built is an event anomaly detection, and anomaly in quotes because it's not technically not technically an anomaly as you would define it, but if you have an event-driven architecture with 600, 700 services, what you're gonna find eventually is that you cannot prevent systems from breaking, and because how we do look for errors today is we either look for error spikes, AppDex indexes, and so on. And the problem is if you have an AppDex defined, but you just see one error that brings like a system down, it's not usually enough to trigger an alert that somebody would investigate. So what you sometimes see is that systems just stop flowing and queues fill up, and you can observe those, but it's gonna happen with microservices if you have a lot of those. And what we're doing here is basically we put a copy of all of our logs to SNS, and then use an to S3, and then we use S3 event triggers to invoke AWS Lambdas. So that's super convenient. Whenever you write something to an S3 bucket, you can actually use those event triggers to invoke an Lambda, and then we just look at those events, put them in the DynamoDB, and capture like a few of those scenarios. What do we have already seen in the last 24 hours? What's the amount of events that we see usually for those? Do we see any new events that we haven't seen before? And did any events like stop bubbling up, right? And this helped us a lot in the past to catch errors very early in production. Another thing that we use, it's the opposite of fast track. We call it GTFO Initiatives, and it stands for Get Out. And it's the opposite of fast track, right? So what we said, we do an initiative, GTFO EC2. And it sounds fancy, but what it is really is like, it's an inventory across all of our teams. How many instances do we have? Who is what they're doing? And then we have like a weekly check-in with all of our teams, and drive that initiative and say, okay, can we help you? Do we need to move resources there? And then try to really get out of a system if we decided that this is something that we want to do. Usually those GTFOs, we have a dedicated Slack channel where we keep all the messaging and so on in a decentralized way. And then if you look, what happened is like one of our engineers, he wrote actually a Lambda function that always, whenever a new EC2 got created, bubble it up into that channel. So for us, it's really meta, right? It's like a Lambda serverless robot gets kind of like cranky at a EC2 creation and then bubbles it up. So, but again, super easy to do. You probably guessed it, like just listens in our SNS system. And what I really like is we celebrated too. If you see here Kalina, what she's doing, right? That her team is going out of EC2, and then she's like, mic drop, boom, I'm out of the channel, I'm done. But we don't just celebrate in Slack, we also celebrate in real world. And in Denmark, we do that mostly through Cake. And so what we have is an IoT button, and we call it the Cake alert. And whenever you press that, it's in our open space area next to the TV. That means there's cake on the table. And so the expectation would be, obviously, if you have get out of a system through GTFO initiative, that there will be some sort of cake. And how this works is very simple. Again, if you haven't seen the IoT button yet, it integrates directly to an AWS Lambda. And then from there, again, you just publish to an incoming webhook to Slack. It's super easy. It's just a few lines of code. So you don't even have to do any API integration or anything. It's really just like a incoming webhook. So Slack gives you a URL that you post it to, and that's it, right? So let's just sum this up. How do we fast-track serverless? We had the serverless first principle, our engineering principles. Then, as I said, hackathons and labs are really popular for serverless. At least we see it, that it's really popular. And then GTFO initiatives, right? In this example, GTFO out of EC2. Okay, and then the last part of my talk is looking back. How do you feel about the last 2 years? Any advice, right? Just checking in, because the time is still on 0, how I'm doing on time. But so 2 years ago, we said, let's do it right. Let's fast track to serverless. We want to be on the forefront of this. And I think really, on that forefront, I think we were successful, right? We could increase the adoption of it. We mostly moved out of our EC2 systems. And yeah, for us, it was the right thing to do. It also modernized our cloud compute stack, right? It enabled us really to move on a few other pieces. And we still have a few remaining systems in EC2. I think that's the goal for us in 2019. Like we have a hard limit for, what is it, Q2, end of Q2 in 2019 to be out of all EC2s, or at least move to like a version where we only have like a few Snowflake systems that are kind of like allowed. And the biggest question that I usually get around AWS Lambda functions is, are they really cheap, all right? If you think back about the principle, one of our assumptions back then was we're going to reduce our cloud compute cost and we're going to reduce our operational costs. And it's really hard to put a finger on it, because if you look at Lambda and you look at like traditional cloud compute, it's really apples and bananas. You cannot compare that, because it's those two things. It's not just your AWS bill and for Lambda and your AWS bill for EC2s, it's also the operational costs that you might find are different, right? All this, the effort that has to be, or has been going into building up those auto-scaling systems, managing those queues, orchestrating those, we see that gone now with Lambda. So it's hard, right? And then if you make mistakes, if your system doesn't scale, that's expensive too. If you think you can do scale better than AWS, or your team can do scale better than AWS, you might pay for that at one point. And so, just to give you an idea, I think we have about 12.5 million invocations a day at Lambda, and I think we pay around $400 US for that. And compared to what we pay in traditional compute, it's really nothing. So kind of my gut feel around that was, for us, and this is like a big disclaimer, right, trademark for us, it feels like they're about 10x cheaper, so like an order of magnitude. And what we really felt is it's less ops heavy. You have an initial investment that you need to make. Use a new way of doing CI/CD to Lambdas, right? And then you have other situations about like mono repositories, and do you need one repository per Lambda, or do you have multiple Lambdas in one repository? And so there's a few decisions that you need to make, but in general, we see it being less ops heavy, and then definitely faster development for services at scale. We just get it out of the box. We don't have to think about it. We don't have to implement it anymore. And one downside, I want to mention that as well for us, is a decrease of observability and traceability. Definitely, if you move from bigger systems into a lot of smaller systems, what you gain in independent systems, like you're going to have to pay in observability and traceability. Like keeping track of all your systems is going to be really complicated, particularly if you reach like 500 plus systems. And We do it kind of in a traditional way today, using X-ray, New Relic, and so on, logging to like really see how our systems like integrate with each other. But we're trying to invest into that in the future, and I think we have particularly an eye on service mesh, bringing like all of our systems together on like one service mesh between virtual servers, containers, and then serverless compute, and map it all out on a service mesh. Also will make it super easy for our developers to build new services and then like hook into those microservice architectures, and you don't have to do a hard job implementing this on your local machine anymore. So yeah, to sum it up, for me, the last 2 years, I would do it again in a heartbeat. And yeah, I think this was the end of it. Thank you.